Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about the problems with rate structure that is implemented in both the hardware and software and how problems can be satisfied with the ZFS checksums and pool of storage facility. Unfortunately, RAID does not always provide all systems or files available to a user. Say for example, a pointer to a file could be wrong and a pointers to a file structures could also be wrong. So the writes that is incompleted and can make us in a corruption of data while writing back into the disk. RAID does not support this type of problems as it only supports the physical media failures but not the hardware and software issues that is solved by the problem. So there are numerous of these hardware and software bugs that presents in the operating system and that perils with all the problems that is not satisfied with RAID as for an incomplete writes, asynchronous writes, other than that the pointer failure or the point loss in the particular data structure. Now the Solaris ZFS that uses the advantage of checksum by including it in the block structures of every disk and provides this checksum to calculate the error, detect it and then correct it in a particular measure. The checksum is a method for verifying the integrity of the data. As we know that the checksum is implemented with all these internal blocks of the disk that is maintained inside this data structure. So whenever inclusion of blocks, that is the data and both the metadata provided by this checksum in ZFS. ZFS stores the checksum for each of the block but not in the same block that is being checksummed but as a pointer to the block. Now consider that an inode structure that consists of file system metadata which contains the pointer to its data. So if there is a checksum block in the inode for the data block, then the checksum will contain the data for that particular situation. Now if the data block is then get mirrored and tell us that if there is any incorrect checksum on that mirrored data and correct checksum on that particular data, so the mismatch will give us that error detection and we can then perform and rebuild on that particular checksum on data block by matching these two types of incorrect consistencies. As well as this checksum of data, there is a checksum of metadata or the inode itself. That the directory structure that points to the inode contains the checksum of that inode. So if there is any problem within the inode, then it can be accessed by the directory structure's checksum block. So now we will see that how this checksums of ZFS is implemented. Here we can see that is a traditional ZFS pointer system. First, the metadata block is pointed to some directory structure. Then the metadata block is containing two addresses for storing the two checksums. One checksum is for the another metadata block, that is a metadata block 2. And the checksums for some other metadata blocks or data are stored in this address 2. Now in the metadata block 2, we can see that two addresses storing the checksum for D1 and D2, that is the data block 1 and data block 2. So the checksum of D1 address points to this actual data block 1 and D2 points to this D2. So this data block and data 2 can be then mirrored, and the mirrored can be then updated bad blocks with the good blocks upon any checksum error or that particular data block. So in this way, pointing the checksum blocks to that actual block makes it that the checksum will not get updated or cranked up if there is any damage to the particular data or metadata blocks. So it is obviously better in terms of reliability than any other sets that is provided by the RAID levels, and also they can perform a good system performance on that particular operating system's memory reference area. As if it is performed on the software basis, then it will give us a better result and better consistency on the data loss. Now, whenever this types of RAID level that is implemented but ZFS is performed over it, then it will be given a better control of the consistency, error detection and error connection than any of the performance issues that is solved within this RAID levels. So all the solutions is provided throughout the ZFS structures. Now the extra overhead of containing this checksum and computing it will definitely overlooked because of the faster access and recovery of the ZFS over the RAID level implementation. Another type of problem related to the RAID level implementation is that the reliability issue. Say suppose we have 20 disks on a particular memory system. Now we are dividing with 5 sets of 4 disks each. And each of the disk is implemented RAID level 5, that is a block interleaved distributed organization. So whenever this type of disk performance is gained, then we can say that this RAID level 5 will not give us the actual result. Say for an example, a volume structure which is too large to fit a set of these 4 blocks inside it, and a volume structure that is too small to hold all the 4 disks of this particular set. So now as the varying volume and sizes, that is the main problem that is concerned with RAID level implementation. Now whenever the volume and the file sizes are known previously, then we can solve this problem with this RAID. But however, very frequently the size of the files and volume get changed during the execution of an operating system services. Now this ZFS provides a more and integrated and efficient structures known as a pool of storage that attach with every host inside that ZFS file and every file system in between this ZFS. Now as the pool can be accessed by any of the file system that is included in the ZFS, now we can provide a higher control over the volume size restriction and the file size restriction. So even if a volume size varies between these, then the file can be chosen for any volume to get allocated. So it will choose a near about size that is of the volume to the file. But it does not allow the file size to get changed very frequently because the file growth is affected and the artificial limit is then preserved by this RAID level implementation. But if we are using this pool of storage by ZFS, then there is no artificial limitation on that particular storage area, and it will then really reduce the access time and increase the CPU throughput, as we can place every read access to the disk that is placed inside the volume. Even if the volume size can vary according to it and there is some restriction to be allowed with the file length that is to be prescribed earlier, then also it is placed inside the volume so that the volume can control it and the file owner can change this type of restriction at any time. So in this way, ZFS produces a better and safe way to solve the problem that was an issue with the RAID level implementation. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.